let's apply some of this dimensional analysis conversion stuff to actual chemistry and density, since we've been talking about that quite frequently. By the end of this video, you should be able to still set up a dimensional analysis conversion magical line to freedom, as I like to call it, and determine the density of any object as long as you can figure out its mass in grams and how much volume it displaces in milliliters. We'll quickly review some dimensional analysis formatting. We'll try a couple warm-up questions just to get you in the mood for math. And then we're going to go into finding the density of a penny. Here's the brief review as promised. We'll make it as brief as possible. Step 1, draw your line, equal sign, another space for your answer. Then you're going to put what you're given on top of the line. So they're going to give you a gift. They're going to give you a value. You're going to put that as the first thing on top of the line, right there, just like I have it there. Then we're going to put the goal units at the end of the line, all the way after our answer space at the end of the line, so we know where we're going. Goal units will always go on top. Again, a good thing to remember, goal goes on top. So we're going to have conversion factors throughout. Those are our domino pieces, and one of those conversion factors is going to have our goal units, and that goal unit is going to go on top of the line in one of our domino spaces. Let's hop right into it. Here's our first warm-up to get you in the mathy mood. We're always going to start by drawing a line. Even before I read this question, I don't care what the question says. I'm going to draw a line. So here goes my line. Woohoo! I'm going to draw an equal sign, and then I'm going to leave a space for my answer. Awesome. I have the first bit of my magical line to freedom complete. Now let's read the question. The moon is 250,000 miles away from Earth, that is. How many feet is it from Earth? Okay, so now we need to figure out, okay, what did they give us? What did they give us? They gave us a number and units associated with it, and that was our gift. So our pretty gift, hopefully you're noticing, is this 250,000 miles. They gave us our pretty gift all nice and wrapped like a pretty present. We're going to put our pretty present as the first thing on top of our line. 250,000 miles. Don't forget the units. Having the units there is half the battle. We need to know what the units are so we know where we're going and how to put our dominoes next to it so we can cancel the right dots, so to speak. Next, we need to figure out what they want from us. What are they asking us to do? It says, how many feet is it from Earth? So feet is what they want. They want that as our goal units. Our goal units go at the very end. So let's put feet at the very end of our line. Great, we have a good setup. Now the last step is to figure out what domino pieces, what conversion factors we need to get from miles here to feet here. The way we bridge this gap is by finding a domino piece that has both miles and feet in it. Hey, cool thing. I have this hint right above my head that says 1 mile is equivalent to 5,280 feet. Now your domino piece can be flipped either way. So let's see our two options for our domino pieces. We have a domino piece that's possible to have 1 mile on top and 5,280 feet on the bottom. Or we can have this domino be the other way around. We can have it be 5,280 feet on top or 1 mile on bottom. We need to figure out which of these two dominoes suits our needs for this problem. We need to get rid of miles and we need to be left with feet. Therefore, we need miles to go on the bottom for our domino piece, and we need feet, our goal unit, goes on top. We need feet to go on top because that's our goal unit. So between these two domino pieces, this is the one that suits our needs, not this one. So I'm just going to plug that domino conversion factor right into my magical line to freedom. 5,280 feet, goal unit goes on top. Woohoo! It is on top, it matches. And 1 mile on the bottom. There's my nice little domino added right there. Now I can go through and make sure that my units do cancel, and I'm left with what I needed, my goal. Miles, since they're opposite of each other, there's one on top and there's one on bottom, that miles can be crossed out. It can cancel itself out. Now all we have to do is plug and chug the math into our calculator. We have two numbers next to each other on the top. Since there's numbers next to each other, we need to multiply them together. And since I'm not going to do that in my head, let's plug that into the calculator. That gives me a really big number with 7 zeros. So 1, 2, 3, 4, 5, 6, 7 zeros. Whew. Okay, so how many feet away is the moon from Earth? 1,320,000,000 feet. Whew, pretty far away. Now here's a warm-up with some metrics. We haven't tried one of these yet. We're going to do it in a way that you're probably not familiar with, but hang tight. This will help you so much in the long run. I promise you, this would make it way easier for you in the future. We are going to solve a problem for Arnold Schwarzenegger and his muscle mass. Before we even read this question, you know the drill. We draw our line, and we put an equal sign and a space for our answer. Cool. If Schwarzenegger had 4.5 times 10 to the 4th grams of muscle, how many kilograms is that? Whew. Okay, so back to our steps as always. What do they give us? What do they want from us? They gave us 4.5 times 10 to the 4 grams. That was our pretty little gift. We're going to put our gift as the first thing on the top of our line, very beginning. 4.5, and now I'm going to put an E instead of times 10 to the. If you don't know why that's the case, please watch my previous video on how to use the EE button in your scientific calculator to make these kind of calculations way easier. 4.5 E to the 4 grams. Don't cheat your units. Always write the units. If you don't write the units, you don't know what dots on the dominoes need to be canceled or how those dominoes need to be flipped. Always write the units. Next, we need to figure out what's the goal. What do they want from us? They want us to figure out kilograms of muscle in Arnold Schwarzenegger. So we're going to put kilograms at the end of our line. That's where we're going. That's what we want. It's at this point that you might feel stuck. You might go, well, I know that kilo is 1,000, but what do I do with that 1,000? How do I plug that into this format that Decanta is making me do? It's really easy. This is why when you think about milli, centi, and kilo, I want you to think about it in terms of 10 to the power of something. In this case, kilo would be 10 to the power of 3. When we plug this into our dimensional analysis format, if I want units of kilograms, the only difference between this G here and this G here is that there's a K in front of it. Cool. Well, K is literally 10 to the power of 3. That's a kilo. Kilo is 10 to the power of 3. So if I want units of K in my end product, I'm going to put a K on top. Because K times G gives me kilograms. But K comes with a number. There's a number associated with K, and that number is 10 to the power of 3. So that's what we need to plug in down here, 10 to the 3rd power. Now we have a domino that gives us the units we want in the end and a mathematical way of how to do this. There's an invisible 1 implied in front of the K whenever you put a letter or a number or anything. There's always an invisible 1 there. So the 1 times the 4.5 e to the 4 still gives me 4.5 e to the 4. But now what we want is to divide this by 10 to the 3. So essentially what we're doing is just dividing 4.5 E4 by E3 in our calculator. How would this look, you might ask? Let me show you. 4.5 in the calculator. And if you don't remember from before, we're going to push our second button, and then we're going to push the comma button for our EE value. And you'll see an E has now populated on my calculator screen. Now I need a 4 for that raised power, so we're going to plug in a 4 as such. Now we need to divide that by, so divide sign here, divide that by E3. So again, second, comma, and then 3. E3. All we have to do now is hit enter. Ta-da! So our answer is 45 kilograms. If Schwarzenegger has that many grams of muscle, he has 45 kilograms of muscle. Jawohl, mein Herr. Ist so stark. Now that our joints are all nice and lubricated with our mathy dimensional analysis setup, let's apply it to something chemistry, finding the density of a penny. We know that the density units are grams per milliliter. So we need to find mass, grams of pennies, and we need to figure out how much water it displaces, milliliters, and then divide those two numbers that we find in order to determine the density of said penny. I have here a lovely scale, and I also have a stack of pennies. There are 10 pennies here, and we're going to figure out how much these 10 pennies weigh. You might ask, why is she using more than one penny? Because my scale isn't that great, so it needs more weight on it to actually read the mass. So I need more than one penny, so here we are. Okay. It looks like it comes out to be 0.9 ounces, 0.9 ounces. So let's write that down. 10 pennies comes out to be 0.9 ounces. So we have 10 pennies are equal to 0.9 ounces. Okay, that's great and all, DeConta. I thought you said we needed grams, not ounces. Like, why do you have ounces written down instead of grams? We can't find density with ounces because the units are in grams. I'm glad you're paying attention. Yes, we're going to do a conversion in order to get from ounces to grams. So what we want to see here is that 1 ounce is equivalent to 28.35 grams. Great. Now, the next thing that we need for density is a milliliter value. We need to figure out how much water displacement 10 pennies can do. So the other thing we need is a graduated cylinder to measure the water displacement. I have 10 milliliters of water in this graduated cylinder here, and we're going to just plop in our lovely little pennies and see how far the water goes up from there. Alrighty. We now have pennies in the graduated cylinder. The water has risen substantially. So we want to figure out, okay, where is that volume line now? To me, it looks like the volume line is at 14 when I keep it on a level surface. So what we can say then is that our initial in the graduated cylinder was at 10 milliliters. It's now at 14 after we added the pennies. So the pennies made the water level rise 4 milliliters. Again, we had 14 milliliters. Now it started with 10 milliliters. So what we have is water rising 4 milliliters from where it started. That's our water displacement. Okay, this is where our conversion comes in handy. We have to draw our magical line to freedom, equal sign, space for our answer. We know that we have ounces. That's what we got in our experiment. We have 0.9 ounces worth of pennies. Yeah, that's a penny. It's horrible. It's atrocious. I'm so sorry, Abe Lincoln. And we know we're trying to get to grams of pennies. So our conversion factor is going to be this guy right here. 1 ounce is equivalent to 28.35 grams. We could write that as 1 ounce over 28.35 grams as our domino, or we could write it as 28.35 grams over 1 ounce. In this case, we need a domino that cancels out our ounces, which is already on top. So we need an ounce on the bottom, and we want goal units of grams, and our goal units always go on top. So that would be this domino here to be plugged in on our line. 28.35 grams over 1 ounce. We can now see that our ounces cancel, they go away. We're left with gram units, so that means we're on the right track. Now we just have to plug and chug into our calculator. Anytime we have numbers next to each other, we multiply them together. We have 0.9 next to 28.35, so we're going to multiply those two numbers together in our calculator. And what we get from that multiplication is 25.515. So we had a mass of 25.515 grams of penny, and that mass moved water 4 milliliters. Since we know that density's units is gram per milliliter, we're going to take our gram value and divide it by our milliliter value so that we literally put units of grams over units of milliliters. 25.515 grams divided by 4 milliliters gives us our goal units in the end. Now we just need to actually do the division with our numbers. Plugging into a calculator, we have 25.515 divided by 4 gives us 6.37875. Don't forget the units at the end. Those don't go away. Just because we divided 25.515 by 4 doesn't mean that grams per milliliter can suddenly disappear. We now have the density of our 10 pennies altogether. So if that's the density of our pennies, what is the density of copper? We need to go into our MSDS scavenger hunt to find the density or the specific gravity of copper and see if these pennies truly are made of copper or is it something else. So just with a quick Google search online, I was able to find MSDS for copper, and what we can see here is that the specific gravity, which is again synonymous for density, is 8.94 grams per milliliter for copper. That doesn't match the value we came up with. That must mean that there's something else in our modern day pennies other than just copper, because if it was copper, it should be 8.94 or somewhere close to that. But we had 6 something. That's way off. So we actually have some other kind of metal mixed in with our pennies. In fact, nowadays, our pennies are predominantly zinc, actually. The inside of the penny is all zinc, and it's just coated with a really thin layer of copper on the outside. So although our pennies used to be entirely copper, now they're mostly zinc. And that's why the density we discovered in our little experiment is not the same density that's reported in an MSDS. Overall, there's some key takeaways that I want you to leave this lesson with. The first being, don't make math harder than it has to be. It's already pretty difficult for most of us. I know it was and still is in lots of cases for me. So as long as you are organized with your numbers and your units, that bookkeeping is a huge part of it. So be sure that your bookkeeping is on point and that you are keeping track of your units. Brings me to my second point. Always know and write out your units, no matter how redundant it seems to be. I know when you're doing these conversions and you put the line and the units just seem like they take so much extra time, but guaranteed, if you keep track of those units, that brings me to my third point. If you plug in the units and you have no idea what you're doing, you don't even know if you're doing it right. But if you're keeping track of your units and your units all cancel out to leave you with the goal unit you were trying to calculate for, 9 out of 10 times I found that you're going to get the right answer. Again, even if you have no idea what you're doing. So just being good and vigilant at keeping your units where they need to go and keeping track of them in that bookkeeping will help you answer pretty much any math problem that has to do with conversions as long as you follow these steps. If this video was helpful for you, please hit that thumbs up button and give me a like. Subscribe to my channel if you haven't already. Wishing you a very happy new year out there, 2021, and let's hope that 2021 is not as ducked up as 2020 was.
No ducks, no glory.